There's a moment scientists do not like to talk about. A moment on January 15th, 2022, when every instrument on Earth, every satellite, every pressure sensor, every seismograph on every continent registered something that had not been recorded in over a century. Not a nuclear bomb, not an earthquake, a volcano underwater in the middle of the Pacific Ocean. And within 11 hours, it had rewritten the rules of planetary science, erased an island from the map, and quietly injected enough water vapor into the stratosphere to alter the chemistry of the upper atmosphere for the next decade. Nobody warned you. Nobody fully explained it. And even now, the effects are still unfolding. That is the first thing you need to understand before we go any further. Because what happened on January 15th, 2022, in the waters of the South Pacific Kingdom of Tonga was covered, briefly, dramatically, then filed away in the global news cycle like it was a natural disaster with a beginning, a middle, and a neat, tidy end. There were satellite images. There were tsunami warnings. There were dramatic headlines about shockwaves circling the globe, and then, almost as quickly as it appeared, the world moved on. But the Earth did not move on. On January 15th, 2022, a volcano on the floor of the South Pacific exploded with enough force to punch a plume 35 miles into the sky. 35 miles. Think about that for a moment. Commercial aircraft cruise at about 6 miles above the surface. Weather systems, the ones that produce hurricanes and blizzards and droughts, operate in the lowest 6 to 10 miles of the atmosphere. This eruption went past all of that. It punched through the troposphere, through the stratosphere, all the way into the mesosphere, into the boundary where Earth's atmosphere starts becoming outer space. The eruption column rose 58 kilometers into the mesosphere, the highest recorded eruption column since Krakatoa's in 1883, which extended up to 80 kilometers high. And scientists expected the usual aftermath: sulfur aerosols drifting upward, some temporary warming in the upper atmosphere, surface temperatures cooling modestly for a year or two, the classic volcanic aftermath that textbooks had described for generations. Instead, something completely different happened, something that 3 full years of international research have only recently begun to explain. The atmosphere cooled in a layer where it was supposed to warm, and 3 years of international research were needed to explain why. This is not a story about a natural disaster. This is a story about how a single geological event broke our understanding of how the planet works, and how its consequences are still quietly reshaping the world above your head right now in ways that most mainstream coverage has never once explained to you. And let us go back to the beginning, not to the eruption itself, but to what came before it. Because what most people are not seeing is that this event did not appear out of nowhere. It built, slowly, silently, like a pressure system that the world's most sophisticated monitoring equipment was watching in real time, but simply did not know how to interpret correctly. In December 2021, an eruption began on Hunga Tonga-Hunga Ha'apai, a submarine volcano in the Tongan archipelago in the southern Pacific Ocean. The eruption reached a very large and powerful climax nearly 4 weeks later on January 15th, 2022. For those 4 weeks, the world mostly ignored it. There were small explosions, some ash, some steam rising from the water's surface. Scientists who had been monitoring the island since 2015, when new land had literally risen from the ocean floor and joined 2 existing islands together, were watching with interest, but not alarm. For the first few weeks of 2022, the volcanic activity seemed typical enough, with intermittent small explosions of tephra, ash, steam, and other volcanic gases, as magma and seawater interacted at a vent near the middle of the island. And then everything changed. At approximately 4:47 p.m. local time on January 15th, the significant eruption reached its peak. The main phase of the eruption lasted approximately 11 hours. 11 hours. In those 11 hours, the Hunga Tonga-Hunga Ha'apai volcano did something that no other eruption in modern recorded history had done on quite the same scale. Described by scientists as a magma hammer, the volcano at its height produced a series of 4 underwater thrusts, displaced 10 cubic kilometers of rock, AXE, and sediment, and generated the largest atmospheric explosion recorded by modern instrumentation. 10 cubic kilometers. To give you context for what that actually means, imagine the entire island of Manhattan. Now stack it 300 feet high with solid rock. Now imagine all of that material violently displaced in a matter of hours. That is approximately the scale of what happened beneath the surface of the Pacific Ocean on that Saturday afternoon. But here is where it gets worse. The explosion was not just large, it was, by the measure of the instruments built to record such things, unprecedented in the modern era. It was the largest explosion, recorded in the atmosphere by modern instrumentation, far larger than any 20th century volcanic event or nuclear bomb test. NASA determined that the eruption was hundreds of times more powerful than the bomb dropped on Hiroshima, hundreds of times more powerful than a nuclear weapon. And yet, in the weeks that followed, most of The world's population did not understand the full implications of what that phrase actually meant. Because what the cameras from space captured, those extraordinary satellite images of a perfect white mushroom cloud expanding across hundreds of miles of open ocean, was only the visible surface of a catastrophic event whose deepest consequences were happening in ways that no camera, no matter how sophisticated, could photograph. The eruption produced a volcanic tsunami that affected Tonga, Fiji, American Samoa, Vanuatu, New Zealand, Japan, the United States, the Russian Far East, Chile, and Peru. Read that list again. That is not a regional disaster. That is a planet-scale event. Tsunami waves generated by a single underwater explosion traveled across the entire Pacific Basin and reached the coastlines of South America. In Peru, a country more than 10,000 kilometers away from Tonga, 2 people drowned when 2-meter waves struck the coast without adequate warning. Because the tsunami warning systems that exist to protect populations around the Pacific were designed almost exclusively to respond to earthquakes, not volcanic eruptions. Tsunami warning systems are primarily focused on earthquake-generated tsunamis, which make up nearly 90% of the historical tsunamis in the world. This eruption exposed a catastrophic blind spot in the global early warning architecture. The world's most vulnerable coastal populations were being protected by a system that was not built for what just happened. And this is where everything starts to compound. In Tonga itself, the island nation that sat at the center of this catastrophe, the damage was immediate, total, and in some places, apocalyptic. The eruption triggered tsunami waves of up to 15 meters which struck the west coast of Tongatapu, Oahu, and Ha'apai. Ashfall covered an area of at least 5 square kilometers, damaged the international and domestic undersea. Telecommunications meant little information was available from Tonga following the eruption. Think about what that means. A nation of roughly 100,000 people had just been struck by the largest explosion on Earth in over a century. Tsunami waves the height of a 4-story building were washing through coastal villages. Volcanic ash was raining from the sky and contaminating fresh water supplies. And the rest of the world was watching satellite images in silence because the undersea cable connecting Tonga to global communications had been severed. Tonga had gone dark. Completely, terrifyingly dark. Ash from the eruption made landfall on the main island of Tongatapu, blotting out the sun. Loud explosions were heard 65 kilometers away in Nuku'alofa, and small stones and ash rained down from the sky. Many residents in Tonga were stuck in traffic whilst attempting to flee to higher ground. For days, the world did not know how bad it was. Surveillance flights from New Zealand and Australia painted a picture of destruction that even the most experienced disaster response officials described as devastating. New Zealand Defence Force and Australian. Defence Force's surveillance flights on January 17th showed significant damage to houses, roads, water tanks, and other infrastructure on the west coast of Tongatapu, the Ha'apai Island group, and the west coast of Eua. All 7 resorts along the northwestern tip of Tongatapu, including the Vakaloa Beach Resort, were destroyed by the tsunami generated by the volcanic eruption. 7 resorts gone. Entirely. The islands of Namuka Iki, Mango, and Tonumea were also particularly hard hit, with ocean surges washing over low-lying areas. On some of these smaller islands, there was essentially nothing left above the waterline that had not been touched, knocked over, contaminated, or erased. Communities that had existed for generations, that had survived cyclones and floods and the grinding poverty of small island life, woke up on January 16th to find their world fundamentally altered. According to the World Bank's rapid assessment, around 600 structures in total, including at least 300 residential buildings, were damaged or destroyed by the tsunami waves, with an estimated $43 million in damage from the waves alone. Tonga's agricultural sector was significantly impacted, with 85% of agricultural households nationwide affected to some extent. 85%. Nearly every family in Tonga that grew food, kept livestock, or maintained a garden found themselves looking at damaged or destroyed crops, contaminated soil, and futures that had been violently rearranged. The damage to the economy from the eruption and tsunami was estimated to be equivalent to $182 million US, or more than 36% of Tonga's GDP. But the real story, the one that is still not being told clearly enough, is not just the immediate physical devastation, it is what happened in the months that followed, and the months after that, and the years after that, because the aftermath of what happened on January 15th, 2022, has been quietly reshaping lives, ecosystems, global weather patterns, and the chemistry of the upper atmosphere in ways that most people have simply never been told about. Almost 20% of survey respondents went at least one full day without eating, a doubling of the pre-crisis level. Food insecurity was especially prevalent in areas of Tonga most heavily hit by the disaster, and among poor households. 1 in 5 households could not access routine health care after the disaster. These are not statistics from the first chaotic days after the eruption. These are findings from surveys conducted months later, in April, May, July, and August of 2022. People who had survived the initial catastrophe were still going entire days without food, still unable to see a doctor, still living in the shadow of an event that the rest of the world had largely forgotten about by February. A third of households in the disaster-struck islands lost boats and canoes. Agriculture activities and tourism jobs were severely disrupted. About a third of workers in those sectors had not yet recovered their incomes at the time of the second survey in July and August of 2022. Think about the particular cruelty of that. Fishermen in Tonga had not only lost their boats to the tsunami waves, even the fishermen whose boats survived could not go back to work because of toxicity warnings about the ocean water contaminated by volcanic ash. A 74-year-old fisherman from the village of Patangata had his fishing boat sunk and destroyed during the tsunami, leaving him unable to make a living. My village's main source of income and livelihood come from the ocean, but the waves damaged the majority of our boats. We sold seafood daily, but now there's none. Anyone whose boat was not destroyed no longer goes fishing due to toxicity warnings, he said. A man who had spent his entire life working the ocean, forced to stop, not because of the waves, but because of what the volcano had left behind in the water. And then, as if the world had decided that Tonga had not endured enough, the first local outbreak of COVID-19 arrived immediately in the wake of the disaster, carried by the very relief ships bringing aid to the island. The first local outbreak of COVID-19 happened straight after the disaster, further exacerbating the impacts on Tongans suddenly hit by multiple shocks. A nation already staggering under the weight of its worst natural disaster in living memory now had to simultaneously manage a pandemic outbreak with a healthcare system that had been compromised by the eruption, with international relief workers restricted in their movements, with an economy that had just lost 36% of its annual output in a single morning. It showed that water vapor can drive climate shifts. It proved that sulfur can vanish into the sea, where it can remain hidden from satellites and ice, and it confirmed that submarine volcanoes deserve far more attention than they have received. And here is the part that should make you pause for a moment and think seriously about what this means. The Tonga-Kermadec volcanic arc, the subduction zone that runs from New Zealand up to Fiji and contains the Hunga Tonga volcano, is part of the highly active Tonga-Kermadec Islands volcanic arc, a subduction zone extending from New Zealand to Fiji. This is one of the most geologically active regions on Earth. It contains dozens of submarine volcanoes, many of which have not been comprehensively mapped or monitored. Before January 2022, the scientific community did not have a clear understanding of how much climatic danger a submarine eruption at this scale could generate. Now they do. But what the new understanding also reveals is that there are potentially dozens of other similar geological features around the Pacific Ring of Fire, around the world's oceans, that represent risks whose full magnitude we have simply never had the tools or the framework to assess. What most people are not seeing is that Hunga Tonga did not just destroy an island and displace a population and generate a planet-wide atmospheric anomaly. It also revealed a gap in humanity's understanding of its own planet, a gap that sits at the intersection of volcanic science, climate science, tsunami warning systems, and emergency preparedness that the event of January 15th, 2022 has only partially begun to close. Meanwhile, on the ground in Tonga, the slow, grinding work of recovery has continued far from the world's cameras and attention. Communities from smaller Tongan islands required resettlement, and roads, communication, and other vital infrastructure were damaged. The tourism industry was brought to a standstill, and vital supply chains as well as fisheries and agricultural activities were heavily disrupted. Tonga was still recovering from Cyclone Harold in 2020 and Cyclone Gita in 2018, with Cyclone Ian in 2014 also still relatively fresh in Tongans' memories. This is the reality of life in the front line of the Pacific. Not a single catastrophe from which you recover, but a relentless sequence of geological and meteorological violence from which recovery is always incomplete, because the next event arrives before the previous wounds have healed. The families, who were evacuated from the most severely affected outer islands to the relative safety of Tongatapu, Tonga's main island, faced a particular kind of invisible crisis. Their homes were gone. Their community structures were gone. The social networks, the fishing grounds, the agricultural plots that their families had worked for generations. All of it was inaccessible or destroyed. And in the immediate aftermath of the eruption, even the relief supplies that were being mobilized by Australia, New Zealand, and the international community could not be easily distributed because of the COVID-19 protocols that Tonga itself had maintained with extraordinary discipline throughout the pandemic. The arrival of international relief ships threatened to introduce the virus that Tonga had successfully kept out for nearly 2 years, as Tongan Minister of Finance stated, with communications and logistics still a major challenge. This report, supported by the World Bank, provides us with a clearer picture of the extent of damages from this catastrophe and will inform our next steps as Tonga builds back stronger. Build back stronger. It is a phrase that appears in disaster recovery documents with the optimistic regularity of a government press release. But what does it actually mean for a nation of roughly 100,000 people spread across more than 170 islands, sitting in one of the most geologically violent regions on Earth, whose entire annual economic output had just been damaged to the tune of 36% in a single morning? What does building back stronger mean when the infrastructure that was destroyed, the undersea communications cable, the port facilities, the roads along the western coastline, the water supply systems, all of it needs to be rebuilt in a location that is guaranteed, by the fundamental nature of Pacific geology, to face another catastrophic event? When? No one can say. Where exactly? No one can predict with certainty. But the probability of another major geological event affecting Tonga is not a question of if, it is a question of when. According to informed sources monitoring the long-term recovery trajectory, the rebuilding of Tonga's telecommunications infrastructure alone took months. Months during which families could not reliably communicate with relatives abroad, during which the diaspora communities in New Zealand and Australia that send critical remittance payments back to the islands were cut off, during which the digital economy that Tonga had been slowly building was completely suspended. And the economic consequences of that communications blackout compounded every other form of damage in ways that are extremely difficult to quantify, but deeply materially real. And then there is the science that is still emerging. The science that is, right now, being published in peer-reviewed journals and discussed in international atmospheric research conferences, but that has not yet made its way into the public conversation, with anything approaching the clarity and urgency that it deserves. The Hunga assessment report's main findings include the eruption increased global stratospheric water vapor by about 10%, much of which remains in the atmosphere in 2025. Very large eruptions usually cause a stratospheric warming effect, but Hunga did the opposite, cooling the stratosphere, the layer of air approximately 10 to 50 kilometers above the ground. This cooling effect was not trivial. This massive water injection cooled temperatures in the tropical stratosphere by 4 degrees Celsius in March and April of 2022. In turn, this temporary cooling created a secondary circulation pattern that led to reduced ozone levels throughout 2022. 4 degrees Celsius of stratospheric cooling from a single eruption. To understand why that matters, consider that the stratosphere is not simply the passive ceiling above the weather system we inhabit. The stratosphere interacts with the troposphere below it. Changes in stratospheric temperature and chemistry influence the jet streams, the pressure systems, the circulation patterns that determine where rain falls and where drought persists and where hurricanes form and where they do not. The atmosphere is not a collection of separate layers stacked neatly on top of one another. It is a deeply interconnected system in which a disturbance in one layer propagates through all the others. The study confirmed the combined effects of the eruption's water vapor and sulfur dioxide created a dipole response of stratospheric cooling and warming. This indicates the critical role of stratospheric water vapor in long-term atmospheric chemistry and dynamics. A dipole response, cooling in one region, warming in another simultaneously, driven by the interaction between the water vapor and the sulfur dioxide that Hunga Tonga injected into the stratosphere in different proportions than any previous eruption scientists had studied at this scale. Both events happening simultaneously from a single eruption had no precedent in the instrumental record. No precedent. In the entire history of modern atmospheric science, in all the data collected from all the volcanic eruptions studied since the development of satellite monitoring, since the establishment of global weather observation networks, since the invention of the instruments capable of measuring stratospheric chemistry, this eruption produced a combination of effects that had no precedent in the instrumental record. And it happened under the ocean, quietly, beneath the surface, in a part of the world that most of the global population could not place on a map without assistance. What the real story is, and what the layers of this event keep revealing as you peel them back, is that January 15th, 2022, was not just the worst day in living memory for the people of Tonga. It was also the day that a single geological event quietly demonstrated the limits of what humanity thought it understood about the systems that sustain life on this planet. The limits of the tsunami warning systems that protect hundreds of millions of coastal residents. The limits of the climate models that guide policy decisions about the future of the atmosphere. The limits of the scientific frameworks that categorize and assess volcanic risk. The limits of international Disaster response in a world where a nation can go completely dark, cut off from communication for days at a stretch, while its population faces one of the most violent natural events in a century. A new study, published in the Journal of Climate, explores the climate impacts of this eruption. The findings show the volcano can explain last year's extraordinarily large ozone hole, as well as the much wetter than expected summer of 2024. The eruption could have lingering effects on winter weather for years to come, not months, years. And the water vapor anomaly that is driving those effects, the HTHH MOC project, found that global climate models accurately simulated the Hungas. Volcanic eruptions' impacts, with a water vapor anomaly lasting 4 to 7 years, and causing significant ozone depletion in the upper stratosphere for 7 to 10 years. 7 to 10 years of upper stratospheric ozone depletion from one eruption. On one afternoon, in the middle of the Pacific Ocean, the people of Tonga are rebuilding slowly, with the resilience that characterizes communities that have no choice but to be resilient, that have never been given the luxury of fragility because the geological reality of their home does not permit it. They are rebuilding houses and repairing roads and replanting crops and relearning how to fish in waters that the ash of a submarine volcano temporarily made. Treacherous. They are carrying forward the memory of what happened on January 15th, 2022, in the way that communities carry the memory of catastrophic events, not as history, but as a presence, a knowledge, a permanent recalibration of what is possible, of how quickly the ground beneath ordinary life can become something unrecognizable. And above them, in the stratosphere, 3 billion tons of water vapor continue their slow journey through the upper atmosphere, interacting with ozone molecules, influencing circulation patterns, cooling layers of air that should be warming, creating conditions that scientists predicted 2 years before they materialized and are still working to fully model for the years ahead. The eruption is over. The island that existed, the one that had been literally created from the ocean floor in 2015, that NASA scientists had been monitoring as a living laboratory for the formation of new land, is gone. The volcanic eruption destroyed an island and created many mysteries. But here is the question that no one has fully answered. Here is the uncertainty that lives at the center of everything that has been discovered in the 3 years since the cameras from space captured that extraordinary, terrifying image of a perfect circle of white fire expanding across the Pacific. If this one eruption, from a single submarine volcano in a remote corner of the South Pacific, was capable of injecting enough water vapor into the stratosphere to alter the global ozone layer, change weather patterns in Australia 2 years later, and produce atmospheric effects that scientists now project will persist for the better part of a decade, how many other volcanoes of similar or greater size sit beneath the world's oceans, unmonitored, unmapped, unaccounted for in the climate models and tsunami warning systems and disaster preparedness frameworks that the world relies upon? How many of them are building pressure right now? And if one of them erupts tomorrow, or next year, or in 10 years, with an energy release comparable to or greater than what Hunga Tonga produced on January 15th, 2022, will the systems put in place to protect the world's coastal populations, to warn the communities in the path of the waves, to model the atmospheric consequences, and prepare the international response? Will those systems be ready? Or will the world once again find itself watching satellite images of an extraordinary event, generating dramatic headlines for a news cycle, and then moving on, while the real consequences unfold quietly, invisibly, for years in the chemistry of the air above and in the lives of people who were already carrying more than the world ever stopped to notice? The eruption of Hunga Tonga-Hunga Ha'apai is over. The cameras have long since moved on. But the atmosphere remembers. And somewhere beneath the surface of the Pacific Ocean, the geology has not finished what it started.